T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
HER roll program is in progress. Vehicle pod rates look good. Booster PU has gone to fixed angle, confirmed. SRB chamber pressures have plateaued. I'm rolling off. Signatures look good. RD-180 operation looks excellent at this point in the flight. Mach 1. SRB chambers continue to roll off. Max Q. Boosters throttling up. We're on schedule. Engine response looks good. Booster P has gone to closed loop control. Looking for our SRB throttle down momentarily. Engine continues to operate well. And booster has throttled back. Looking for SRB burnout soon. Chamber pressures have plateaued on the SRBs. And we're beginning to roll off. And BOTA has been satisfied. Vehicle is starting back up to full thrust. And we have solids 1, 2, 3, 4, and 5 jettisoned. Visual indication that all solids have separated well. And the booster has begun its roll for spacecraft thermal constraints. Rates look good. Bus and battery voltages are stable. And the vehicle has now gone into closed loop steering. And booster PU is also in closed loop control. Engine response looks good for the set mixed ratio. Current altitude is 45.8 miles in altitude. Downrange distance 69 miles. Velocity 5,413 miles per hour. Coming up on our RCS pyro valve activation. It is now fired. System's now pressurizing to flight levels. We've begun our 2.5 G throttle segment. Engine response looks good. Current altitude is 60 miles in altitude. Downrange distance 118 miles. Velocity is 6,983 miles per hour. Coming up on our next mark event will be payload fairing jettison, followed by the CFR jettison. And we have payload fairing jettison and CFR jettison. Boosters throttled back up to full thrust. Engine response looks good. Now accelerating at 4.7 Gs as we work our way to our 5G throttle segment. Boost phase cooldown is underway. Now throttling to maintain 5 Gs. Pogo pyro vent has been fired. And begun throttling to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. We have BECO. Engine shutdown looks good. We have retros and stage separation. We have LOX and fuel pre-start. RCS GN2 purge firing is underway. We have ignition and full thrust on the RL-10. Centaur closed loop steering has been enabled. Small body rates associated with closed loop steering. Vehicle tank pressures are being ramped down as expected. Centaur PU has been commanded to oxidizer-rich fixed angles for the early part of this 6-minute and 2-second burn. Current altitude is 112 miles. Downrange distance is 589 miles. Velocity is 14,318 miles per hour. Range track shows the vehicle right down the middle of the corridor, making excellent progress.
Welcome to Jupiter, the largest planet in our solar system, 300 times more massive than Earth. If it doesn't look impressive from this distance, well, just wait. We're cruising with NASA's Juno spacecraft. Look around. You can find Jupiter, Juno, and the Sun. Now we're flying with Juno during one of its more than 30 orbits of Jupiter. Juno's main mission is to learn more about how Jupiter formed and how the planet works from the outside in. All we can see now are the tops of the clouds, but Juno's sensitive instruments can look deeper, beneath the clouds and churning storms. Speaking of storms, don't miss the Great Red Spot, a swirling, crimson-colored vortex twice as wide as Earth. Juno's orbit takes it over the poles and just 3,000 miles above Jupiter's clouds, closer than any other spacecraft has come before. These close encounters allowed Juno to map Jupiter's gravity, magnetic field, and water. Turn to see two views of Juno, in regular and X-ray vision. The three panels are solar arrays, each about 30 feet long. Juno would just fit inside a professional basketball court. Jupiter is so far from the Sun that sunlight here is 25 times weaker than at Earth. See the saucer-shaped antenna on top? That's the main way we communicate with Juno. Below the antenna is the vault, a titanium box to protect Juno's sensitive electronics. Now you're inside the X-ray view of Juno. Look for the round blue and green tanks. They hold rocket fuel to help Juno adjust course when needed. Look up and see the honeycomb structure of the main antenna. Below the antenna are multicolored boxes, which are electronics in the vault. Looking down, you'll see the bell of the main rocket engine.
And while there are no astronauts on board, Juno carries 3 Lego minifigures made of aluminum: the Roman god Jupiter, the goddess Juno, and the famous astronomer Galileo, who in 1610 became the first explorer to turn a telescope toward Jupiter. What Galileo saw through a telescope, we will explore up close with Juno. Learn more about the mission at nasa.gov/Juno and missionjuno.swri.edu.